Hi, friends. In this lecture, I am going to discuss problems based on Hinge reaction and conservation of mechanical energy. Let us see first one. See the question given. Three particles A, B, and C, each of mass m, are connected to each other by three massless rigid rods to form a rigid equilateral triangular body of side L. This body is placed on a horizontal frictionless table, that is XY plane, and is hinged to it at the point A so that it can move without friction about the vertical axis through A as shown. The body is set into rotational motion on the table about A with a constant angular velocity omega. We can see diagram here. Find the magnitude of the horizontal force exerted by the hinge on the body. At time t, when the side BC is parallel to the x-axis, a force F is applied on B along BC as shown. Obtain the x component and the y component of the force exerted by the hinge on the body immediately after time t. So asked for 5 marks in 2002. Let us see how to start the problem. So first make the diagram, that given diagram. Given now 3 point masses, three particles, identical masses m, m, and m, connecting by massless rigid rods, each of length m. And see, they have taken the CSA, B, and C, and they have taken this is x-axis and this is y-axis, right? So first see what we have to find. Given omega is a constant, it is given omega which is a constant. So we have to find magnitude of horizontal force exerted by the hinge on the body. So whenever they ask about the force, we have to focus now center of mass. Okay. Now center of mass following circular path, right? You can see a center of mass means this will be centroid. Okay. It is a centroid, center of mass. And you can see it's a distance. Suppose centroid is now somewhere here. Take it as this is now D, point D. The length AD will be equal to 2 by 3 times, means 2/3 part of root 3 by 2L. Okay. That means AD value how much? L by root 3. Means distance of center of mass from axis of rotation is L by 3. That means center of mass follows now circular path of radius L by root 3. Okay. And condition given that omega is a constant. Omega constant means there is only centripetal force. and see who provides now centripetal force. It is given that this arrangement is on a horizontal plane. So horizontal plane means mg means weight of the system is balanced by normal reaction, and these two forces are along vertical. Okay, that means the only force that is now towards center is hinge reaction. That means hinge reaction has to provide centripetal force. So I'm writing directly here, hinge reaction providing centripetal force. So centripetal force equal to mass into, since we are focusing center of mass, that means we are assuming the entire mass of the system at that point. So its mass is 3m. Okay, m r omega square, r value L by root m r omega square. This is now centripetal force. This is how much? Root 3 em L omega square. So this is equal to hinge reaction. Okay, that is the first part. Now second part. At time t, when the side BC is parallel to x-axis, a force F is applied on B along BC as shown. Right. Now second part. A force F is applied. Okay. Just after applying the force. Condition is just after applying the force, we have to find x and y components of the hinge reaction. Again, see carefully. Before force was applied, omega was a constant. Just after applying the force, just after means omega does not change. Okay, since we are making calculation just after applying force, so omega does not change. That means centripetal force remains the same. That means y component of hinge reaction is again equal to Fc only. This is nothing but y component of hinge reaction. Let us call it as F suffix H. Hinge reaction. This is now y component. Okay, towards center. So now we have to find out for a hinge reaction x component. Okay, then see what we can do. So let us focus now force equation along x-axis. Now center of mass follows circular path like this. Okay, at this instant, applied force along the tangent, right? Hinge reaction. It may be along positive x-axis or maybe along negative x-axis. And that we are not knowing right now. So we simply assume that it is also in the same direction. That means F plus, let us take this as some F dash, okay? I'm taking this as F dash. This is X component of hinge reaction. F plus F dash. This force is now along a tangent. Okay. This force is along a tangent. So net force along a tangent. It is a tangential force, mass into tangential acceleration. And AT value, R into alpha. R value how much? L by root 3. Right? L by root 3 into alpha. So now see how to get the value of alpha. Now we have to focus how to get the value of alpha. So to find alpha value, we have to focus torque equation, right? But till now, that is what we have done. And about which axis we take torque equation? About which axis the body is rotating, means about origin. So if you take about this, then torque will be F into perpendicular distance. That is how much? From here to up to midpoint of BC. That is root 3 by 2L. This is now torque about origin. That is equal to I into alpha. Okay. And when you take I value about origin, see how much? It is equal to ml square into 2 because of B, ml square, because of C, again ml square, right? And because of A, it is on the axis. So I value 2ml square, right? And that is equal to torque equal I into alpha. Then see alpha value how much? L gets cancelled. Alpha equal to F root 3 upon 2 2 so 4. This is a 4ml. Okay. So 80 value. Then see 80 value how much? 80 value L by root 3. L by root 3 into alpha. Alpha is now F root 3 upon 4ml. L gets cancelled. It is F by, oh, wait. Yeah, what we are doing here? Right. It is AT equal to R into alpha. It is root 3 gets cancelled F by 4m. Now take that here and see one more thing here. We have take here 3m because we are taking the force equation for center of mass. Okay. So in this now substitute value F plus F dash is equal to 3m. 3m into 80. 80 value F by 4m. 80 value F by 4. This is now 3f by 4. Okay. That implies f dash equal to how much? Minus f by 4. And why we got minus means? Its meaning is hinge reaction that is along negative x-axis. Means x component is along negative x-axis. And its value is now f by 4. Okay. Modulus value. Therefore, hinge reaction is now, if you want modulus value, square of the x component and square of the y component. Okay. Now in this they're asking only what is x component and what is y component. Only these two, not the magnitude. Okay. If they ask magnitude, take sum of the squares under root. That means in all these cases, see what we are doing to find a hinge reaction. We are taking force equation for center of mass. Right? Let us see next problem. Two blocks of masses m and m, small m and capital M, are connected through a light string going over a pulley which is free to rotate about its axis. The pulley has a moment of inertia I and radius r. Find the kinetic energy of the system as the block m falls through a distance h, the speed of the blocks at this instant. Let us see how to start the problem. First, make diagram for the given data. So it is nothing but Atwood machine. So having a pulley and having a two blocks, small m and a capital M. Okay. Given for the pulley, moment of inertia I Let us see solve. Okay. So we have to find out first of all their velocities, and we want to find out their velocities. See the question once what they have given. We have to find out their velocities, right? Okay, first one, kinetic energy of the system, right? Okay. When it falls through a distance h, then speeds, right? So when this heavier block, say heavier blocks moves down, when this moves down by a distance h, we have to calculate the kinetic energy of the system. And this we can say directly because when this moves down by distance h, we can write loss in the gravitational potential energy converts into kinetic energy for the system. Okay. So here system means these two blocks as well as pulley because here pulley also rotating, right? Since the pulley rotating, it is also having kinetic energy. So kinetic energy of the system is equal to, so here we are assuming that capital M is greater than small m. That's what is moving down. So loss in the gravitational potential energy, M minus M into GH. See carefully, capital M GH. It has come down, small m GH going up. So what is loss? This is loss. This loss converts into kinetic energy for system. Okay. Next, we want to find out speed. And while finding speed, we should be very careful. Kinetic energy for this one of mv square for smaller block of smaller v square plus for the pulley kinetic energy half phi omega square. And see in the place of omega, what we have to write? In the place of omega, if you observe carefully, condition is no slipping between the pulley and string. That means if you take a point on the pulley, velocity of that point and the contact point on the string, both points must have same velocity. And because of rotation, velocity equal to r omega. That means in the place of omega, what we have to write? It is V by R. Okay. This is now kinetic energy of the system. And that is equal to M minus M into G into H. Okay. So like this, by using conservation of mechanical energy, we can find the speed of each block. Okay. The other way of solving the question is by using kinematics. Okay. Let us see how to solve by using that. We can say this is method one by using conservation of mechanical energy. You can see method two, that is by using kinematics. In the last lecture, we have discussed how to find acceleration. Okay, acceleration is given by, I am writing here directly, m minus m into g upon, you can guess the value here, m plus I by r square. This is acceleration. Okay, acceleration is known. Displacement, that is h. Initially velocity is 0. Final velocity we want to calculate. Acceleration is a constant, right? So we want to find out, we want to find out V1. Displacement is given. Then equation is V square minus U square equal to 2AS. So by using kinematics also we can find this answer. So method 1 by using conservation of mechanical energy. Method 2 by using kinematics. Okay.